Hello everyone. In this video, we'll understand about queuing theory. So we may notice here a picture where there is a queue being formed waiting for some service. Waiting for service is part of our daily life. We wait to eat in restaurants. If it is jam-packed, we queue up at counters in grocery stores. Cars or any other automobiles, they stop at traffic lights, waiting for the signal to give them clearance. Jobs wait to be processed on a machine. Planes circle in a stack before landing. We cannot eliminate waiting without incurring some inordinate expenses. So, in our day-to-day life, waiting has become a part of our daily life itself. Now, why do we study this queues? So basically, we are studying queues to understand about how much is the average queue length, how much waiting time is required. If this much of waiting time is required, do we need to add some more service channels or service centers to cater those services? Is it worth investing, etc.? The study of queues deals with quantifying the phenomena of waiting in lines using representative measures of performance, that is average queue length, then average waiting time in the queue, and average facility utilization, means whichever is the service channel, that utilization. So let us consider this particular table where somebody has collected a data stating that if he has got one counter, the total waiting time, average waiting time is 16.2 minutes. If there are two counters, then the average waiting time is 10.3 minutes. If there are three counters for their particular service, it takes 6.9 minutes. If they put up four counters, then the average waiting time reduces to 4.8 minutes. If they put up five service channels, then it becomes 2.9 minutes average time. If they put up six counters, then the average waiting time further gets reduced to 1.9 times. And if they put seven counters, the average waiting time further reduces to 1.3. So currently, there is a fast food center restaurant, which is called Ganesh Charts, having three service counters currently. Their manager did this particular study because they received complaints from their customers about slow service, and the results of his survey gives this data, what we saw in the beginning. So now it is very clear, like if he has to achieve, let us say, 3 minutes average waiting time, then currently they have three service counters that they need to add up two more service counters to reduce the average service time to 2.9 minutes, which is slightly lesser than 3 minutes. That means if the manager wants to reduce the average waiting time to 3 minutes, then he need to add two more counters. So that decision can be taken from this particular data. So just one understanding, why do we need to study queues with this particular example. Then we may notice that if we draw the level of service and cost in the form of a graph, keeping that level of service in x-axis and cost in y-axis, we may know that once I try to improve my service, slowly the cost also will go up. And if I reduce my service, the cost may go down. So here, when the cost of waiting here, customer per unit time, how much time they are waiting. Here it is cost of the operation for improving the service, cost of operating the service facility per unit time. So there is an intersection of these two curves, and both of these costs together together becomes the total cost. So here we try to focus that we consider it as an optimum level of service. So how do we achieve the optimal level of service is our main objective in queuing.